I'm going to talk quickly about the interval notation and specific to that. So now I can spend a lot of time on solving or setting up from word problems, really just about the interval notation and how to write that. So I'm going to start with these two problems. I just made these two up, or this problem, I guess. This one problem. I made it up. And so it says we have this expression here, this inequality, or this other inequality, which means that my final solution, it has to work for one or the other. It doesn't have to work for both at the same time, but any solution that I find, any value for x that I find, it has to work for either this one, or both, but at least one or the other. I'm going to solve it. So for this one over here, I'm going to solve on the left. I'm going to take away 1 from both sides of the inequality, and I'm going to get that 3x is greater than or equal to 9. I'm going to divide both sides by 3. Excuse me. I'm going to get x is greater than or equal to 3. Solve that. I'm going to do the same thing here. I'm going to add 4 to both sides of the inequality. I'm going to get that negative 2x is greater than, that's a greater than. Now the 76 is greater than 10, that would be. I'm going to divide both sides by negative 2. Remember, if you divide by a negative or multiply by a negative, you need to flip this sign around. I'm not going to go into why in this video. You just have to trust me that you need to. So we have our two inequalities. We've solved them both. It's or. Now, rather than jumping straight into the interval notation, I'm going to graph it simply because I like having a visual. It helps me to kind of get a pictorial image of what's going on and why the interval notation works. You don't have to draw a picture, not necessary, but I'm going to. So there's two solutions that I found here, two markers anyways that I found, 3 and negative 5. So I'm going to put those on here, and I'll put 0 on just to give it a reference. My graph is not perfect. As you can see, they're not equally spaced. There's nothing else on there, but it's going to give me an idea of what I'm doing. X is greater than or equal to 3. To graph that, it could be equal to 3. So I'm going to put a closed in circle there. It means that 3 could be a solution. And x could be greater than 3. So any number going in this direction, 4, 5, 6, 7, 8, 9, all the way up to infinity and beyond, is going to work for that inequality, just this part. Or x could be less than negative 5. Not equal to negative 5, though. So I could be like negative 5.000001, and that would work. But I could never quite get to negative 5. And x is less than negative 5, that will work. So anything down to negative infinity. All right, so I've got a visual idea of what values will work for this problem, this inequality or that inequality. So I need to write it in interval notation. When you're writing in interval notation, I find it easiest to read from left to right and say, okay, what's the smallest value for x that will work in this original inequality here? And the smallest value is negative infinity. Just keeps on going. Negative infinity. And then I'm going to keep going to the left. I'm reading from left to right. So I guess I'm going to the right here. So I keep going negative infinity. I've got this marker here at negative 5. So I've got this stopping point. Negative 5. So anything from negative infinity up to negative 5 will be a solution to at least one of these two inequalities, this one specifically. Negative infinity is not a number. It's an idea. You could never get to infinity. If you did, that would be amazing, but you can't do it. So we're going to put a parenthesis because it'll never equal negative infinity. I'll just get close to it, as close as we can anyways. Negative 5, same idea. We're never going to quite equal negative 5. It's just going to get really super close to negative 5. So I'm going to put a parenthesis. For the next one, I'm going to keep reading from left to right. There's nothing in between here that works. None of these values for x will work for either of these inequalities here. But I've got negative 3. I can include negative 3. Negative 3 would work here. X could equal negative 3, or excuse me, positive 3, sorry. Could equal positive 3. So starting with 3. And again, going from left to right, it just keeps on going up through infinity. So I'm again going to put infinity. This would be a positive infinity. Infinity is not a number, so I'm going to have a parenthesis there. You will always, always, always have a parenthesis for infinity or negative infinity because they're not numbers, and it can never equal infinity or negative infinity. 3, it could equal 3 and work for this set of inequalities here, this compound inequality. So I'm going to put a closed bracket. I want to be able to use either this set of numbers here or this set of numbers here. So I'm going to put a union in between. I'm going to say any of these values or any of these values will work for this compound inequality. That's the interval notation right there. I'm going to do one more, very similar. I'm going to spend a lot less time going through the specifics, so I'll speed up if you're getting sick of hearing me talk. I'm going to change it ever so slightly, though, so more or less the exact same. But you'll notice how the slight difference changes it. This is going to be and. So this compound inequality, whatever values of x that I find have to work for both this inequality and this inequality. I've also changed the direction of those inequalities, and we're going to see what happens. So solving it is the same thing. I'm going to get 3x less than or equal this time to 9, and x greater than or equal to 3. Less than or equal to 3. And for this one, again, negative 2x less than 10. I flip the sign, x greater than negative 5. Okay, so I solved them, same idea, except the inequalities are flipped. Graph it. Throw 0 in there just because. Okay, this time, let's see, x is less than or equal to 3. So including 3 and anything less than 3 will work for this inequality. Any value of x over here will work for this inequality. X is greater than negative 5. So I'm going to put, again, open circle. It'll never quite equal negative 5, and greater than in this case. Because this is an and problem, it has to work for this inequality and this inequality at the same time. What I want to look for is, where do these two lines overlap? And they're going to overlap from here to here. Everything in between is where those two inequalities overlap. Beyond 3 to the right only works for one of them, not both. Beyond negative 5 to the left only works for negative 5, but not both. Only works for one of them. So I would draw my inequality like this. That middle line right there. That's the final answer for drawing the graphing, the inequality right there. For the interval notation, again, I'm reading from left to right, and I'm only looking at this spot where the two graphs overlap, because it's and. So I'm going to start at negative 5, not negative infinity, because this is where they overlap. I'm going to say negative 5. They overlap, they overlap, they overlap, they overlap. This is where they stop overlapping, at 3. I'm not going to include negative 5 because of the way my inequality was written. Just things strictly greater than negative 5 will work. I am going to include 3 because it could be less than or equal to 3. So this is how you would write the interval notation for this inequality or compound inequality right there. Hopefully that helps.